Good day, pre-algebra. We're here with PO34, writing the equation of a line in slope-intercept form, which of course we know is y equals mx plus b. We've been working with that for a few lessons now. But we're writing the equation in slope-intercept form, given an equation in what is called standard form. Okay, and basically the idea of this objective is learning how to manipulate an equation, rewrite an equation to make things easier for us. Okay, we know how to graph in slope-intercept form. You got the slope, got the y-intercept, easy. But if the equation is given to you in standard form, there's a little bit of work to do to put it into that slope-intercept form. And so fill in this line here, slope-intercept form, y equals mx plus b. And then standard form looks like this, ax plus by equals c. Okay. And one thing I want to point out here is that this capital B in standard form is not the same thing as the lowercase b in slope-intercept form. That's why one's capitalized. That's why one is lowercase. This lowercase b has a very specific purpose, right? It's the y-intercept of the line that we're going to graph. This a, b, and c here just represent numbers, right? So we have some number a multiplied by x plus some number b multiplied by y equals some number c, right? What I want you to take away from this is that what do you notice about the location of our x and y variables when you compare slope-intercept form to standard form? What's different about the location of x and y? Yeah, Pierce. Right. Here, x and y are on the same side. Right? Whereas in slope-intercept form, you've got one on the right side of the equal sign and one on the left side. They're on different sides. Okay? So at the heart of what we're doing today, converting from standard form to slope-intercept form, we essentially want to get y by itself. We want to move that x term over to the other side, okay, and then isolate the y variable, because that's what's unique about slope-intercept form. Y is by itself. Okay, so the two steps to convert from standard form to slope-intercept form. Step number one, we're going to move the x term to the other side using opposite operations. Just like we talked about before with solving an equation, whenever we move something from one side to the other, that sign always changes. That's because of opposite operations. Okay? You can't just take something on one side of the equal sign and put it on the other side. You have to move it there. And the process to do that is opposite operations. Step two is you're going to divide all terms by the coefficient to y. Divide all terms by the coefficient to y. And it's that act that gets y by itself. Right? Step one takes that x term and moves it to the other side, which is what we said is the difference between the locations. Okay, slope-intercept form of as x and y on opposite sides. So step one moves the x term there. Step two is what gets the y variable by itself. So this first one here, 6x plus 3y equals 21. Okay, our first step is move the x term to the other side using opposite operations. So what do I have to do to that positive 6x to move it to the other side? What am I going to be doing to both sides of my equal sign here? What is the opposite of having a positive 6x? John? A negative 6x, right? So we're going to start here by subtracting 6x from both sides. Okay? Because what that does on the left side, where we have a positive 6x, we take 6x's away, and now there are no more x's on the left side. So we've achieved our first goal, which is to get those x's on the other side of the equal sign. And that leaves us with 3y equals negative 6x plus 21. Why can't I combine those to get 15x, 21 minus 6x? Why is that not 15x? I mean, 21 minus 6 is 15, so why isn't 21 minus 6x 15x? Sasha? 21 doesn't have an x, right? They're not like terms. And we can't combine things with addition and subtraction that aren't like terms. We don't have 21 x's there that we're taking 6 x's from. It's just the constant 21. Okay? And notice how I put my negative 6x first. The reason for that is because we're going to slope-intercept form that has that x term first. Okay? So if you wrote 21 minus 6x, you just have them in the reverse order. You want to put that negative 6x before the 21. And the reason why I'm adding 21 here is because the 21 is positive. Okay? Kind of keeps that sign. All right, step 2. It says divide all terms by the coefficient to y. What is the coefficient to y? Yeah, 3. So I'm dividing everything by 3. All terms get divided by 3, which includes the 3y, that includes the negative 6x, and it includes the 21. On the left side, dividing 3y by 3 achieves exactly what I want, which is to get y by itself. Those 3's cancel out, and y is by itself. On the right side, what's negative 6x divided by 3? Negative 2x. And what's positive 21 divided by 3? Anybody? Sorry, did I say nobody? Anybody? 21 divided by 3. Sing it out. In 7, right? Positive 7. So our equation here in Slope-Intercept form is going to be y equals negative 2x plus 7. And so if I ask you to graph this now, right, you'd first put your point at positive 7 on the y-axis, because that's the b. And then from that point, we have a slope of down 2 over 1. Down 2 over 1. Okay? So the purpose of the objective today is to take an equation that's not in slope-intercept form and put it there so that we will be able to graph it. I want to move this up so we can see a little bit better and a little bit higher on the page. But any initial questions? You've done only one of them, so I don't expect you, don't feel bad if you have questions, but anything that you want to verbalize. Aiden.
At the beginning, what's the first step again, with the negative 6?
The first step was to move the x term to the other side using opposite operations. So 6x being the x term, and since it was positive, to move it over, we would have to subtract 6x from both sides. Okay, so in this next one here, with a positive 4x, what would our first step be? Subtract 4x from both sides. Yeah, John.
You did divide by 3 because there's a 3 right there.
Correct, because that was the coefficient to y. So in this next one, when we do it, what's the coefficient to y? Negative 5. So we're going to divide by negative 5. Yep, and we'll do that one together. Anything else? Okay, so let's. I'm going to clear this. I'm going to scroll down a little bit, and we'll do the second one together here. Okay, 4x minus 5y equals 20. Step 1, move that x term over using opposite operations. We have a positive 4x, so our first step is going to be to subtract 4x from both sides. So on the left, if we have 4, we take away 4. Now we have none. No x is left. Make sure that negative sign with that 5y comes along, negative 5y. And on the right side, we can't combine those because the 20 doesn't have an x. And so we're just going to put our negative 4x in front and then add 20. It's a positive 20. We're adding it. Okay? And this is starting to look like slope-intercept form now because we have that x term and then a constant. Okay? Our second step is to now divide by that coefficient to y, which, as John said, is a negative 5. So divide all terms by negative 5. Okay? So if you're kind of following along with our steps up above, here was step 1, subtract 4x. Here is step 2, divide by negative 5. On the left side, those negative 5s cancel out, which is what we want. Y is by itself. And on the right side here, before you take out your calculator to take negative 4 divided by 5, why don't we want a decimal? Which is what your calculator is going to give you if you take negative 4 divided by negative 5. But why don't we want a decimal here? Ifan? Right. If we're going to graph this, we want this to be a fraction because this is going to be our slope. Okay? So all we're really looking to do here is think about that fraction negative 4 divided by negative 5. I'll kind of write it separately up here. What does that simplify to be? Not as a decimal, but as a fraction. What does that simplify to be? Well, what are the numbers 4 divided by 5? Is there any factor you can pull out of there? No. So the 4 and the 5 will stay. And what happens with the two signs? Negative divided by a negative is a positive. So negative 4 divided by negative 5 is simply going to be positive 4/5. Right? And we want that to be a fraction because that is our slope. Okay? And then that 20 divided by negative 5 is what? Nope. 20 divided by negative 5, negative 4. Okay? Negative 4. It's negative here because it's a positive 20 divided by negative 5. That gives us negative 4. And so this would be your answer, your equation in slope-intercept form. Okay? These notes are pretty important here because it's difficult to look at the original equation and see how you get to this. Maybe you can see the connection between the 4 and the 5 there, but between the signs and then how do I get from a 20 to a negative 4? What did I do there? Understanding these steps is pretty critical here. Okay? Questions on that one? Okay. The third one. Negative 10x minus 3y equals negative 36. Look at that x term there, a negative 10. What are we going to need to do to move that negative 10x over to the other side? Add 10, right? In the first two examples, we subtracted here, minus 6x, minus 4x. That's because the x term in the first two was positive. But here, that x term is negative, negative 10x, which means we're going to be adding 10x to both sides. Okay? Always opposite operations. Always opposite operations. Negative 10 plus 10 is 0. That's why we do it. Get rid of all those x's. And that leaves us with a negative 3y equals positive 10x. And this time it's going to be minus 36. Okay, because it's negative there. In the first two, it was plus 21 because the 21 was positive, plus 20 because the 20 is positive. But with that negative 36, it's positive 10x minus 36. Signs play a huge role here. What are we going to be dividing by now to get y by itself? Yes. Leah. Negative 3. Good. And everything gets divided by negative 3. The negative 3y, the positive 10x, and the negative 36. On the left side, negative 3's just cancel out. y is by itself. On the right side, 10 divided by negative 3. Does it work out evenly? No. Do we really care? No, because that should be a fraction anyway, right? So 10 divided by negative 3, that's just going to give us a negative 10 thirds. Negative 10 divided by 3. Okay? We want that fraction. And then negative 36 divided by negative 3 gives us what? Aiden? Positive 12. So this is going to be a plus 12 at the end there. John?
Other question, did you forget that plus on the other side? Or the plus 3?
Are we talking about the second one or the third one? Second one?
Yeah. Are we supposed to put a plus there?
Where?
Oh, never mind. No, put it subtract. Never mind. Sorry.
Oh, you're fine. Okay. Yeah. Okay. Other questions on this? Okay. Your homework for tomorrow. Let me just see what we got. Yeah, well, okay. Homework for tomorrow. I only want you to do the first 3 in this Mr. Heavy Pencil section here. Just the first 3 for homework tomorrow. You got 10 minutes to work on it now. Okay. So it was a heartbreaking number game today, but we can get our vindication as early as tomorrow with 3 questions and 10 minutes of class time to work on it, getting them done. Okay? But remember your steps. First step, using opposite operations. Move that x term over. If your x term is positive, like it is in the first one, you're going to start by subtracting it, right? If it's negative, as it is in the second and third one, you'll be adding it to move it over to the other side. In that second step, you're dividing by that coefficient to y. Make sure you're dividing all terms by that coefficient to y, and pay attention to your signs. Okay, I will kind of walk around and make sure folks are on the right track here, but just these 3 for homework tomorrow. Anything more for me? Okay, that's all I have for you with gusto. That's how you math.